Welcome to Natural Habitat Adventures Daily Dose of Nature. Today's topic, Yellowstone moose, kings of the forest, presented by wildlife biologist Aaron Bott. I'm your host, Rob Bess. Thank you all so much for being here today. Over to you, Aaron.
Thank you, and thanks everyone for tuning in today. I think that moose are fascinating animals, some of the most charismatic that we have in the Northern Hemisphere. And so I'm excited to be talking today specifically about moose in and around Yellowstone. Yellowstone is the world's first national park and is a very popular destination for travelers. And Natural Habitat Adventures offers some great trips, both in the summer season and in the winter season, where you can get out and see these really magnificent animals. So without further ado, we'll jump into it. By way of introduction, I am a professional wildlife biologist. I work for government agencies and I'm affiliated with non-government organizations working on large mammalian conservation. Most specifically, I work with large carnivores, specifically wolves. I did my graduate research in Yellowstone National Park on wolves and am currently employed as a wolf biologist, and I am also working on a doctorate on wolves. So they're kind of my specialty, but I have had the opportunity to work with a lot of other large mammals that are native to Western North America, including moose. Moose and wolves have typically an overlap in their range, and it's been my pleasure to grow up around moose and to work around moose, and even participate in studies where we capture and collar moose in order to better understand their spatial distribution on the landscape. So I think moose are really, truly a fascinating species. And hopefully you're tuning in today because you think the same. And if not, then maybe I'll be able to convince you just how cool they are by the end of today's presentation. Now, I'm specifically talking about moose in the Greater Yellowstone Ecosystem today. And if you're not aware, Yellowstone is a 2.2 million acre national park, mostly located in northwestern Wyoming. About 96% of it is in Wyoming, and you have 1% in Idaho, and 3% of the park is in Montana. And it is in an area that is commonly referred to as the lower extent of the Northern Rocky Mountain Range. The Northern Rocky Mountains really have their distal end in southwestern Wyoming in the Wind River Range and kind of through the Teton Range, and they expand ever northward up through Canada into the Yukon. So this really cool cordillera is what we call it, of high elevation where we have a lot of coniferous forests, which are important for moose. We'll get into that in just a minute. But just to the south of Yellowstone National Park, we have Grand Teton National Park, which was created in 1950. So younger in comparison to the world's first national park, Yellowstone, which was created in 1872, but also very important habitat for moose and a really iconic location where travelers get to go and visit majestic peaks that rise over 13,000 feet from a valley, which is about 5,000 to 6,000 feet. So really a dramatic mountain range there. And this is Yellowstone. Yellowstone gets its name from the Yellowstone River, which is a major tributary to the Missouri River. And we created this national park in order to protect the geothermal oddities that are so popular in this area. It wasn't originally protected as wildlife habitat, but as we've barreled through the 20th and now the 21st century, we appreciate just what this national park system does to protect and preserve habitat for many of our most iconic native wildlife species, including grizzly bears, bison. Next week, I'm going to be giving a presentation on the Yellowstone bison herds, some endemic species such as Yellowstone cutthroat trout. Of course, we have incredible conservation success stories such as the reintroduction of the native gray wolf in the mid-90s and we have some of the largest elk herds in the world found in this ecosystem, which also therefore include the largest migratory herds in the world regarding elk and some other species such as mule deer and pronghorn. And in this suite, we can include moose as being one of those really iconic species. But we, as I mentioned, have Yellowstone National Park, which is 2.2 million acres. And then just to the south, we have Grand Teton National Park, which is about 500,000 acres. It's important to realize that these national parks are built by arbitrary human political boundaries that are invisible on the landscape, and animals don't recognize these boundaries. And more importantly than the national parks is the vitality of the Yellowstone ecosystem, or the Greater Yellowstone Ecosystem, which encompasses the surrounding topography of this country, including the Wind River Range, the Gallatins, all the way up into Montana, down through Idaho and Wyoming, and makes up about 16 to 20 million acres, depending on who you talk to. So all of this country is really what I'm going to be referring to when I'm talking about Yellowstone moose. So not specific just to Yellowstone National Park, but to the surrounding country as well. Now, we're going to begin by talking a little bit about the evolution and the biology and the behavior of moose, as well as a little bit of the natural history and human history of moose coexistence before we start talking specifically about Yellowstone's population. And if you are interested in moose, then Yellowstone is a great place to go and see these incredible animals on the landscape. Moose are cervids. That is, they are deer. In fact, they are the largest extant deer in the world right now. So during the Pleistocene and thousands of years ago, we had larger megafauna, larger cervids that have since gone extinct. But today we have moose in the Yellowstone ecosystem, as well as elk, and we have mule deer and white-tailed deer. So 4 species of deer can be found in the Yellowstone region. And again, moose are the largest. Moose in the Yellowstone area can get up to 1,000 pounds, so quite large. The males are referred to as bulls, and the females are referred to as cows, and their offspring are called calves. And they typically reproduce 1 calf every year. And unlike your very gregarious elk population, moose are typically solitary. Occasionally, bachelors will get together in small herds of maybe 2 to half a dozen or so, but generally moose are very solitary, and they are reclusive as well. And we'll get into a little bit of the details as to why that is in a moment. But not only do moose have the largest body mass of any cervid, they also produce the largest antlers. And we'll talk a little bit about Antlerogenesis, or the formation of these incredible secondary sexual characteristics that they display just in time for their reproductive season in the fall. Now, is it a moose or is it an elk? If you are tuning in from Europe or from Asia, you might be a little confused regarding what today's topic is on. Hopefully not too confused, but just so everyone is aware, in Eurasia, moose, our North American moose, are commonly referred to as elk. In fact, the scientific name, Alces alces, is simply a Latin translation of elk, elk, or what we're familiar of elk being. But when Euro-Americans first began to colonize on the eastern shores of North America, they somehow got their vocabulary mixed up. And we here in North America have what we call elk, which are very closely akin to red deer, Cervus elephas or Cervus canadensis. But somehow everything got muddled and mixed up in translation. And so moose is perhaps an Algonquin word, an indigenous North American word, which reputably is illustrative of the animal's diet. It's referencing, or is a rough translation of, an animal that eats twigs and leaves. So moose is an indigenous North American word, although perhaps roughly bastardized. And we call very frequently the elk here in North America wapiti, which is again another indigenous North American term referring to the white rump of these animals. But if you're again traveling over to Europe, especially in Scandinavia where they have lots of moose, you're frequently going to hear them called elk. So just a little bit of a mix-up, which is again why it's important when we as scientists are writing papers on the species that we clarify with their scientific name. Alces, alces. But to look at the relation of elk and moose, I think it's important for us to understand moose and all of deer's evolutionary background, the phylogenetics of this animal. You perhaps have seen incredible fossils and skeletons or reconstructions of now extinct cervids, such as the Irish elk here on the right-hand side, or Cervalthes scottii, the giant stag moose here on the left. These incredible animals once roamed across the northern hemisphere during the Pleistocene, or the Great Ice Age. And these animals are an excellent example of what we call runaway selection theory in evolution. These antlers that are produced on these animals are tremendous. They dwarf the enormous antlers of today's existent moose by a long shot. The Irish elk, for example, on the right-hand side, had a span which ranged for approximately 9 to 11 feet in those incredible antlers. And today, the largest moose on record has an expansion of antlers that is about 5, almost 6 feet. So almost double the width these now extinct cervids once had on their heads as they roamed around and they competed with one another for sexual selection and for breeding opportunities. We call this intrasexual selection, where males are trying to compete with other males, and females with intrasexual selection are favoring the animals that have the greatest showpieces to indicate health. It's a fitness indicator, you could say, much like a peacock's fantastic tail feathers are pretty much worthless except for attracting females. These antlers are really overkill. And there's a lot of theories bouncing around out there about why these animals went extinct. And one of the things that is most tossed around is that runaway selection theory in evolution, based off of sexual selection driven by female attraction to ornate antlers, led to basically overexhaustion of the animal's nutrient resources, and the animals basically couldn't handle. They couldn't juggle living with antlers so ornately designed on top of their heads. Moose themselves, Alces alces as we recognize them, originated probably about 1 million to 2 million years ago in Eurasia. And today they are still an holarctic species, is what we refer to them as. They can be found all across the boreal forests of the northern hemisphere, from Scandinavia through Siberia, and then of course through Alaska and across the boreal forests of Canada and into Maine. They are very closely related to a now extinct moose species known as Cervalthes latifrons. And I've got kind of an illustration here as well as an outline of its tremendous antler display. But again, moose now today live all across northern hemisphere, although once they originated just in Eurasia. Moose crossed the Bering Land Bridge relatively recently. We don't find a lot of historical evidence of moose inhabiting the boreal forests of North America before really 10,000 years ago. although many biologists believe that they could have been here as early as 70,000 years ago. But during the Pleistocene, we had what was known as biotic interchange, where a lot of the Earth's water was locked up in large glacial ice sheets, which dropped the sea levels and created this land bridge which connected Eurasia to North America. And moose migrated from Eurasia into North America across this land bridge, just like people did, and many other species. And coming into North America, they had to navigate the large ice sheets that were kind of scattered and pocked all across North America, which ultimately dictated where their distribution and range would be over the next several thousand years. But again, moose are relatively newcomers to North America. In fact, there's some evidence that they arrived approximately the same time that people were arriving here in North America, about 10,000 to 20,000 years ago. And you compare that to other species, such as wolves, which came much later or much earlier, and grizzly bears and other large charismatic species that we're familiar with in North America, again coming across the Bering Land Bridge. Moose are really relatively new. And as they came in across the Bering Land Bridge, they first congregated, of course, in Alaska, but they spread themselves throughout the boreal forests of Canada and ultimately trickled their way down through this northern Rocky Mountain cordillera and made it even into the central Rocky Mountains of Colorado. This is not a great map, so please take it with some liberties, but it kind of shows you a rough approximation of where their range is at. And moose, we'll get into this more in just a minute, but moose are driven to live in habitat which is suited for their diet primarily. And moose are browsers. They depend on woody vegetation, particularly coniferous and willow-based woody vegetation in order to grow. So unlike other cervids such as elk and deer, they're not grazing on grasses and sedges. And so again, their distribution is dictated by where their food source is going to be. And that's a really important factor in understanding just how moose behave and why they live where they live. So moose are foregut fermenters, which means that they have a four-chambered stomach and they ruminate. So when you are browsing on vegetation is very rich, especially when it's green, in essential protein building blocks like nitrogen, which helps your body become large and strong and robust. But in order to take advantage of fibrous and very complexly structured carbohydrates, your body has to have evolved to digest vegetation in a way that is pretty complicated. And moose, mostly browsing on woody vegetation, will consume very fibrous material, which they then swallow and bring into their rumen, and then at a later time they will regurgitate it and they will chew it back in their mouth as cud in order to extract and break down more nutrients and to then swallow it and have everything go through the four-chambered system, the reticulum, the omasum, and eventually the abomasum before it makes its way through the intestines into the cecum, where the cellulose is converted into energy. So a very complicated system in order to extract nutrients. But again, as browsers, moose depend on their complex gut system in order to make a living, which gives them a niche in areas where other deer species are not able to live. So moose live generally in what's called a white and green world. They live in the winter where it's cold, and they live in the snow where it's deep, and they live in the forests where it's green. And because of their complex gut system, they are capable of living in the deep forests and in the deep snows, extracting nutrients from food sources that are otherwise worthless to other herbivores on the landscape. So they can persist in deep, snowy areas as long as they can browse on the tops of the brush and the base of the trees. But there is a cost with eating mostly coniferous forest material and nutrient-rich willow species such as aspens, cottonwoods, and of course river willows. And that is that although you're getting a lot of nutrients, you're not necessarily getting all the vitamins that your body requires. And so moose are famous for being semi-aquatic. And in the summertime, they will go out into deep ponds and they will dive deep and feed off of water vegetation, off of water lilies and other plant material, which is more nutrient rich or more vitamin rich and things like calcium, in order for the moose to have a balanced diet and in order for their bodies to develop. For females who are pregnant, they need these nutrients in order to develop healthy fetuses, as well as to maintain their own skeletal mass from going through osteoporosis. And males not only need these vitamins in order to maintain their own body mass, but also to build those incredible antlers. And in some cases, here's a picture of a quaking aspen. They'll even mark not their territory, but their range on trees as they're kind of browsing in areas where leaves and twigs are not easily accessible. So the nutrients, I think, is very fascinating, specifically with the males that are growing these really complex, showy antlers, kind of like crowns of the animal kingdom. Antlers go through what is called Antlerogenesis, which just means the antler creation process. All of your deer species in the world, with the exception of just 2, grow antlers. And these antlers erupt out of a special organ known as a pedicel at the top of the cranium. And they erupt every year and grow as an exterior bone from the cranium. That's all antlers are. I gave a presentation a couple months ago on antlers, and so you can kind of get more details in that if you're interested. But antlers are just a bone that grows on the outside of the body instead of on the inside of the body. And antlers begin to grow every year in the springtime on all the males. And these antlers on some of the larger subspecies, such as the Alaskan moose, can weigh over 40 pounds apiece, so as much as 80 pounds on top of your head, which is really remarkable. And as these antlers are growing, they are at first covered by what we call velvet, which is a innervated and vascular skin that is very sensitive. Some biologists suggest that it's perhaps the most sensitive skin in the mammalian world. So they're soft, they're tender, they have sensation and feeling, and these are growing at a rapid speed, as much as 1 to, even with moose, sometimes 2 inches a day, depending on the diet and the nutrition that these bulls are able to take in. And again, they really need their vitamins, they need calcium, they need healthy nutrients or diverse nutrients in order to help these antlers grow. In fact, to grow a robust set of antlers requires more nutrients than for a female to develop a full fetus. And as these antlers grow, they eventually harden, they ossify, and during the ossification period, the blood circulation through the antlers is constricted and cut off, and the velvet ultimately dies. And at this point in time, the animals will rub their antlers to shed all of that velvet, and sometimes they'll ingest it as well. And at this point, the antlers have become dead bones, and they lose all feeling. And this is just in time for the rut, or the breeding period, and we'll get into the breeding period in just a minute. But these, again, are often characterized as weapons, but more often than not, they're just showpieces. Females are looking for a large rack with symmetry, something that is going to be an indicator of vitality in a potential mate for production of offspring. And so these bulls produce these large antlers, and everything is driven by hormones and the photoperiod. As the sun is moving across the sky and the seasons are changing, testosterone will begin to peak, and as it peaks, spermatogenesis increases just in time for the rut. The males begin to look for females that they can breed with, and immediately after the breeding season in the late fall, testosterone drops, and this causes osteoclasts, a specific cell, to demineralize around the base of the antler, and the antlers then fall off. They cast them. And this is how the cycle goes, only for everything to begin all over again next spring. Moose are the first cervids to shed their antlers in the Yellowstone ecosystem. They typically will cast their antlers around Christmas and perhaps even into January. Some of the younger bulls might retain their antlers until February or even March, but generally they cast theirs much sooner than the deer and the elk. The elk don't cast theirs until mid to late March, and deer cast theirs usually in January and February. Again, all of this is just to impress a mate. It's all a part of the dance of sexual evolution and attraction. The rut, or the breeding season of moose, takes place in generally September and then into October. So if you're traveling into the Yellowstone country around this time period, that's when you're going to see the males with the largest racks, and you're going to see a lot of moose activity because the breeding season is it's happening. It's going on. So males again and females are generally solitary throughout much of the year, but at this time, males might begin to spar with one another. They seek out females, and females have they just breed once a year, but they do have a polyestrous cycle, which means if they are not impregnated successfully during the first mating, then their body will go through a second estrous cycle, making them receptive all over again during the fall months to ensure that they can successfully produce offspring in the spring. Something that is not unique to moose, but is found throughout many ungulates, many hoofed animals in the animal kingdom. Moose have what's known as a phlegm response, where they have a verumonasal organ in the top of their mouth, the roof of their mouth, which allows the males to smell when females are in heat. And so oftentimes you'll see them kind of doing this almost false call, this almost smelling or sniffing of the air, particularly when they're around females, to determine if she is ready to breed. And moose also have this very charismatic dewlap, sometimes called a bell, which hangs under the necks of both sexes, males and females. And these typically get smaller as the animal gets older, generally because they snag on things or frostbite causes them to shrink. But biologists have determined that these dewlaps act kind of as fragrance necklaces. During the rut, especially the males will wallow. They'll urinate in concave earthen cavities, and they'll roll around where they urinated, and they'll kind of impregnate their dewlap with their own scent, and that seems to drive the ladies wild. Females also utilize this for their own purposes in again, indicating to other males when they are sexually receptive, but it's really they're hanging off of the neck, looking very peculiar, just because it helps to retain scent during the breeding season. Then after having reproduced or having mated successfully, reproduction comes to a full halt about 8 months later in the spring when moose calves are born. Females generally just give birth to one calf every year, and the calf will stay with the mother until she gives birth the following spring. So they typically will drive away their calf not quite a year later, just about a year later, right before she gives birth again. And that is how the cycle of a moose works, basically. During this time, throughout the winter, again, the bulls and the females kind of go their separate ways, and they live tenaciously on a landscape where many other animals migrate out of. Moose as individuals have semi-migratory behavior, where they might move on the landscape based off of the seasonality and go from lower elevations to higher elevations. And interestingly enough, sometimes they move to higher elevations in the wintertime, when in most cases you expect them to be moving to lower elevations in the winter because the snows get so deep. But moose, again, are most specifically looking for old growth forests where they can browse and they can live off of subalpine firs, specifically in the Yellowstone ecosystem, which are less common except for in the mixed coniferous forests or the more old growth forested areas. Now, people and moose have had a long, fascinating history all across the northern hemisphere. Moose are extremely powerful, and today they are arguably one of the most dangerous animals in the world. Some people claim that after hippopotamuses, there are more negative encounters with moose than any other species on the planet. Moose charge people, they're unpredictable, they're very dangerous. I work with a large group of wild animals. Specifically, I've done studies on grizzly bears, and I tell people all the time that I'm more afraid of encountering an ornery moose in the backcountry than I am a grizzly bear. Nevertheless, moose have been prized as sources of meat and also clothing by indigenous peoples all over the world for a very long time, and modern people as well. But it's difficult to catch them. Most of the time it takes crusting or hunting the moose through deep snow in order to bring them down, or because they are a semi-aquatic animal, hunting them from boats and bringing them down and then hauling them back to shore. I think this is also fascinating and worth noting that moose have been semi-domesticated by multiple cultures throughout various times in history, which really isn't surprising. Karl XI of Sweden in the 1600s tried to create a special military force where he led cavalry mounted on moose across some of the Scandinavian steppes, because horses can't make it through extreme terrain as well as moose can. Ivan the Terrible in Russia was famous for outlawing the taming of moose because he was afraid of guerrilla uprisings in Siberia. And moose have been used again throughout a lot of Eurasia for various domestic purposes. And you can see pictures like this anywhere on the internet where people have utilized moose for good reason. Moose are extremely powerful and extremely strong, and can make it through landscapes in boreal areas where horses can't make it. But true moose domestication has never really taken root, and that's just because moose, again, are browsers rather than grazers. It takes an extreme amount of effort to try and produce enough fresh foliage and browse for these animals to subsist off of, and that's just not really sustainable. Not only that, but moose can be highly susceptible to diseases from domestic animals, which makes them difficult to keep. They also don't get along well with horses. Wherever moose and horses are together, moose will attack horses. But we've also since moved away from that, and we've come up with our own modern charismatic caricatures of moose, such as the Rocky and Bullwinkle of Canada, and one of my favorite ice cream snacks, moose tracks. So moose seem to be everywhere in our culture, and it's not very hard for anyone to find some kind of moose insignia or moose logo or moose brand wherever they go. And this is particularly true of the Yellowstone ecosystem. The Yellowstone ecosystem, again, as I mentioned, is located in the southern portion of the northern Rocky Mountains, mostly in northwestern Wyoming. And this map that I've put together here is not an accurate indicator of where moose populations are at, but this kind of shows, if you look here in the upper right-hand corner, which is a much more accurate map indicating moose distribution, how moose live in various locations across North America, but really most of their population is in Canada. It's up above that 49th parallel. But we have an exception because of the dense coniferous forests of the Rocky Mountains. We find moose throughout the Rocky Mountains. There are 4 recognized subspecies of moose in North America. The largest subspecies of moose in the world, Alces gigas, is the Alaskan moose. They grow much larger than the moose we have in the Northern Rockies down here. In fact, the Rocky Mountain moose subspecies, Alces shirus or shirisi, are the smallest of the subspecies found in North America. They have the smallest antlers and also the smallest body mass. Our moose, our big bulls, are about 1,000 pounds, and in Alaska they're about 1,700 pounds. So quite a big difference there. But you can see that we have moose again throughout the Northern Rockies and also into the central or southern Rockies of Colorado, but they don't really range outside of the Rocky Mountains. Colorado and Utah are really the most southerly extents of their distribution. And we have a lot of evidence to suggest that, in fact, in the Rocky Mountains, the Northern Rockies and the Southern or Central Rockies, there were no moose up until about 100 to 150 years ago. Moose, again, are very recent on the landscape. In fact, we didn't document any moose in Grand Teton National Park, where they are now celebrated and famous, until 1913. So moose throughout the entire 19th century were completely absent in all the journals and the descriptions of the explorers and the original first tourists who were visiting the parks at that time. Moose have expanded their range south through various reasons, but one of which is just because it's the way that life works. Animals look for and people look for resources that can be suitable to their needs. And if you look at Yellowstone in particular, you can see that in the northern range, we have a minority of the landscape looks like this. About 10% of Yellowstone actually is made up of this montane riparian area known as Lamar Valley, where people go to see wolves and bison. You can also see a lot of moose here because of the robust willow systems and quaking aspen systems that we have here. But 80% of Yellowstone looks like this. It's a really dense coniferous forest, and not only is it a coniferous forest, but it's a coniferous forest of basically one tree, the lodgepole pine tree, which is not very nutritious to any species, including the moose. But there are parts of the park's interior where we don't have a good grasp on just how many moose are presently on the landscape. And there are a lot of willows and there are a lot of old growth forests that are advantageous to moose populations. But mostly you see moose in Grand Teton National Park, and that's because of the wide riparian zones. Lots of quakies, lots of aspen, and lots of subalpine firs in some of these stands that are very important to the moose. And so as you're traveling through Yellowstone, Grand Teton National Park is probably the primary spot where you're bound to see lots of moose. And they are very charismatic and iconic. You can see them even out on the sage flats as they wander around at the base of the mountains. But again, I think what's important and fascinating is that moose are relatively new to the Yellowstone area. And they had a population boom back in the 40s, 50s, 60s, and 70s, where even in Yellowstone, there was an estimated population of about 1,000 moose. And today, the population in Yellowstone is about 200 or fewer. That's pretty dramatic, and it was very alarming to a lot of people, and still is alarming to a lot of people, including some of my family members who have lived for multiple generations in Yellowstone. They complain about not seeing more moose and they wonder why that is. And as scientists, we've recognized that a lot has changed in the last century. Firstly, moose, we recognize, live in kind of boom and bust cycles. It might be a little bit of an extreme exaggeration. We often think about snowshoe hares living in a boom and bust life cycle, but moose generally will also live in a similar kind of natural history where their population grows and then it tends to shrink. And in the mid 1900s, when moose were first expanding southward, one of the drivers that allowed them to expand southward was the fact that we had eradicated all of our predators. Our grizzly bear populations were almost extinct. Our wolf populations were extinct. Our mountain lion populations were extinct in many areas. And with heavy predator control, the moose population was able to exploit resources. And since our predator populations have increased with the reintroduction of wolves and also with grizzly bears being perhaps an even larger threat to moose calf survival rates, we've seen kind of a stagnation or even a decrease in our moose population. But more than that, we also see that fire is a huge driver for moose. Moose, unlike many other ungulate species, they depend on old growth forests. Now, if you're studying mule deer and elk, it's the complete opposite. Old growth forests do absolutely nothing for mule deer and elk. They need those old growth forests to burn out so that they can have fresh forbs and fresh grazing opportunities as the sunlight filters through down to the bottoms of the forest floor. And whenever we see post-fire elk populations and mule deer populations, we see them generally start to climb. They start to benefit from fires. But moose, it's the opposite. Moose depend strictly on very mature forests where we have mixed coniferous growth, and we also have trees that can grow up above the snow level, which in some cases in Yellowstone is 8 to 10 feet in the winter. They depend on those high old growth forests in order to extract nutrients during the very hard months of winter. And when a fire comes through, it makes it difficult for the moose population. And in 1988, we had the famous Yellowstone fires where 36% of Yellowstone burned. That caused a significant upheaval of the moose population throughout the Yellowstone ecosystem. And with understanding this volatile effect of fires and again, a healthier matrix of predators on the landscape, it has reduced the overall moose population in Yellowstone. And that's not to say that things aren't going to change in the future and that the moose population might stabilize again. But I think it's also important to realize just how new moose are to this portion of the continent. Again, typically they live just in the high boreal forests of the north. And moose today are still a fascinating creature that you can go out into the parks and see, especially around Grand Teton National Park. They are something that I think truly sparks the imagination and is really a fantastic animal, something that seems very primeval and right out of the Pleistocene. I always get a big kick when I see a moose and think about my grandfather and how passionate he was about them. I can see exactly why so many people get excited about moose, and I hope that you all get a chance to see one in the wild as well. And with that, I'll end my presentation.
All right, thank you so much. Now, before we start in with the question and answer session, I would like to remind everyone that you can submit your questions via the question field in your control panel. So let's get to these questions. So, will a moose still grow antlers even if it's struggling to survive, or will they just grow smaller or slower?
So antlers are based off of a few different parts of an equation, several different factors. And one of them is genetics, another one is age and body condition, and that kind of ties in also with the third leg of the stool, which is nutrients. So an animal has to have a good diet in order to produce great antlers. So if you have several years of dearth you know, you don't have a lot of good foraging opportunities, then that will affect the production of antlers. But it won't stop the antlers from growing. Antlers are, again, driven by hormones, and so as long as the hormones are working, then the antlers are going to grow. Occasionally you have bizarre circumstances where an animal is castrated. It gets tangled up in some brush, unfortunately, and it becomes castrated. And in those circumstances, it completely disrupts the antler cycle. Likewise, the antlers are going to be the most impressive when an animal is in its prime. So when it's really young and also when it's really old, the antlers are going to look more pathetic, to put it harshly.
Are the antlers symmetrical?
They are supposed to be, but I mean that's what the moose wants. That's what the females want. Again, it's kind of an indicator of fitness, but very often they're not completely symmetrical. In fact, with moose, they have what's known as a palmate antler, which I think kind of is self-explanatory. It's got this big palm, and usually they have, I think it's like 8 or 9 tines. Those are the points on each antler side, and generally speaking, one side has 1 or 2 more tines than the other. So yeah, ideally they would be symmetrical, but that's not always realized.
Are there any animals that use or even eat the antlers?
Antlers are bones. So I think that a lot of people like the idea of antlers dropping off, and then mice and voles and canines such as fox and coyotes and wolves coming and chewing on them, which definitely happens. We have a lot of rodents that chew on them, but it's important to realize that it's calcium and phosphorus. It's the same makeup as a bone. So yes, antlers are nibbled on by many critters in the environment, but so are the bones of dead moose that are cows that didn't produce antlers. And so are the bones of all animals.
Can you explain what the difference between browsing and grazing is?
Yeah, browsing is specifically referring to the consumption of woody vegetation. Grazing is generally referring to the consumption of forbs and sedges and grasses. So this is important in terms of like rangeland ecology, because when you graze, you're typically eating plants that grow from the base, so basally driven plants. Think about how you mow your lawn, and it doesn't retard or affect the growth of your lawn. But when you're browsing, plants like trees and shrubs, they grow distally from their roots. So their twigs and their branches are experiencing the growth. And so that's why you sometimes hear about over browsing by things like moose and occasionally elk, which also can browse as well, and how that can retard the growth of willows and aspen, etc.
Do we know how the current Canadian wildfires are impacting the moose population?
I don't. I do not have any information on that.
All right. Do we have any idea why the populations of moose in the New England states are growing smaller?
I don't know very much about the New England states. Moose are driven by temperature. They are a boreal species that like where it's cold, and so with climate change, as temperatures rise, it becomes uncomfortable for moose. I don't know if that's specifically applicable to the New England states. There are also, like I said, just cycles in the life history of moose populations, where moose populations tend to grow large and then they tend to shrink and then they tend to grow large. So I'm not sure specifically about the New England states.
Do insects such as ticks affect the moose? Can they actually cause their death?
Yes, they can. Tick outbreaks, winter tick outbreaks specifically, have led to the demise of many moose. A lot of moose that I've investigated doing necropsies. They basically deplete the overall body condition of the moose. So if you're covered in tens of thousands of ticks, you become mangy, if you will, and you're basically being bled to death. So yes, winter ticks are a severe problem in some areas where we have moose.
So just how does one go about domesticating a moose?
Well, I mean, I gave a presentation a while ago on the domestication of wolves. And domestication and taming are two different things. So although I said domestication in a true sense is actually the modification of the gene pool. Taming is different. Taming is exploiting a personality of an animal to be dependent. And I don't know exactly how you would go about taming and therefore domesticating a moose. It would probably involve you know, adopting a moose calf at a young age and then having it become dependent on you feeding it. But that's my best guess.
All right, thank you. So what is the best behavior for humans if we're in the forest and a moose has us in its sights?
Again, moose are extremely predictable and they're very dangerous. I'm more alarmed when I encounter a moose in the backcountry than I am a grizzly bear, and so that's something that's important to consider. One of the best things I could suggest is, you know, you can play ring around the rosy with a moose if it charges at you and is really has bad intentions. If you can try and hide and get around trees where it can't cut corners as well. I've used bear spray on moose before. It's not highly effective, but it seemed to work. But basically backing down, because that moose is not going to back down. It's not a carnivore. It's a tank, and it's gonna stop at nothing to try and squash you. So you gotta back off and give it as much space as possible.
That's some good advice. Well, that's going to be the last question that we do have for today. So I'm going to throw it back to you for your closing comments.
Thank you, everyone. Thanks for tuning in and hearing about moose. Moose are, again, a very fascinating creature, and I hope you all get the chance to go and see one in the wild.
All right. Thank you so much for taking the time to present for us today. And I would also like to thank everyone who tuned in today. Now, if you're interested in information on how you can travel with NatHab, please give us a call at the number on your screen, or you can send us an email at info@nathab.com. Our adventure specialists are happy to help you out. Join us Monday for our next Daily Dose of Nature. You can check out next week's lineup, including registration links, on our website at nathab.com/webinars. We did record today's presentation, and we will have the replay available on our website soon. With that, I will conclude the webinar. Goodbye, everybody. We'll see you next time.